So first off, thank you so much for coming to check out this talk. I was a little worried no one would show up because it is the gloomiest sounding title in the world, basically. So thank you for coming to check it out. Hopefully none of you are depressed just by thinking about this topic. Anyways, today we're going to be talking about something that I really enjoy, the 12 factors of pain and suffering. All right, so just sit back, relax, we'll have a good time. So first off, I'll introduce myself. I'm Randall. I work at a company called Okta. If you haven't heard of us, we're like a web security company. We do stuff around user authentication, user authorization, OAuth, OpenID Connect, stuff like that. If you want to see some of my more cybersecurity focused talks, you can just look them up online. And a little bit about my background. So primarily, I'm a Python, JavaScript, and Golang developer. I got started coding when I was 11 or 12, somewhere around there. So it's been quite a while. I'm getting old now. I've been doing open source for a very long time, so I run a lot of open source projects. I contribute to a lot of open source projects. And for the last 7 years or so, most of the open source work I've done has been around making the internet safer. So building tools for developers to handle authentication, authorization, cryptography, and make it easier. I'm also an author, so I've written tons of technical articles and things like that, but most importantly, I consider myself a builder. And what I mean by that is that ever since I was a kid, I've had the great fortune to have built a number of different applications. Everything from really tiny command line apps that basically only I used to really massive API services with billions of requests per day. And one of the things that's somewhat unique about my experience is that for the most part, I've never really worked with other programmers. Like most of my career, building applications, working at companies, and just doing side projects, I've always been building things solo for the most part. And so because of that, I sort of developed my own set of best practices for web development over all the years. And that's why 6 or 7 years ago, I was really excited to stumble across something called the 12-factor app. Now, raise your hand in here if any of you have heard of the 12-factor app. There's a couple people, cool. Now, raise your hand if any of you are web developers, because this is going to be very relevant to you. All right, a lot more people. So if you're not familiar with it, the 12-factor app is essentially a set of principles. And what they define is how to build really simple, scalable, and dependable web applications. That's really what they talk about. It's a really nice system. Now, instead of me just sort of going through each one of the 12 and explaining what it is and how it works, because everyone hates that, right? It's pretty boring. I thought instead I would just explain all the ways that I fucked them up. Because I don't know about you guys, but I've been programming for about 19 years now, and I fuck stuff up every single day. So I'm sure you all do as well, and no one wants to hear the good stories. People just want to hear the bad stories, right? Like the dirt, the drama. That's why reality TV is so popular. So that's what we're going to do today. I'm going to air some of my dirty laundry, and it's, this talk isn't really for you. It's more for me to just get this off my chest. So it's a form of therapy. So anyways, let's get right into it. The first factor in the 12-factor application is all about managing your code base. Now it sounds super simple, right? You have a code base, and maybe you deploy it. So you have a project, and you deploy that project into different environments. You have production, staging, development 1, development 2, whatever. You have all these environments. And this makes perfect sense to all of you, I am sure. Now, you might be wondering how I screwed this up, so I'll tell you the entire story. So going back quite a few years, maybe, I want to say 10, 11 years ago, something like that. It's been a while now. I was working for this company. I dropped out of college, and I was working for this company. And I was working around the clock. I was trying to prove myself as a developer. And the first big project I worked on was this massive website. It was tnid.us at the time. And basically what we did is whenever someone Googled a phone number, a US-based phone number like this is my cell phone number, by the way. So don't call me during the presentation or it's going to mess stuff up. But what would happen is whenever someone Googled it, we were the first result. And so people would find our website, they'd land on our website, and then we would show them all sorts of information. Like the person's name who owns that phone number, their approximate address, a bunch of metadata. And this was fantastic because guess what? A lot of people Google phone numbers when they miss a phone call. Millions of people a day, actually. And so this website was like printing money for us at the time. And the reason is that we would make $10 in an affiliate commission every time someone would land on the site and purchase an additional report where they could find more information about this phone number. So it's fantastic. So as I mentioned, this was my first big job out of college. I was working crazy hours all the time, and my wife really hated that. So she was like, hey, look, you've been working 16 hours a day for like 2 years. Let's go on vacation. So we scheduled our very first vacation trip. We went to Santa Cruz in California, which is sort of where I'm from. We had this nice beach house, and as soon as I get to the beach house, no joke, I get a phone call from my boss, and he said, hey, we have a little bit of a problem. I was like, all right, what's going on? He said, well, our website has no users on it, which is extremely not ordinary. So I checked it out, and basically this is what happened. Google banned us from the index. So they de-indexed our site. And this happened in February of 2010, I think, when Google rolled out their Panda search algorithm update. It was a really big deal. It banned a lot of sites that had certain criteria like ours. And at the time, no one knew what was going on. I didn't know what was going on. So what I did is I opened a support ticket with Google, and I assumed that there was some mistake and they would eventually unban me. But then I also thought, well, if it takes a while for Google support to get back to me, I better launch another site so we can start monetizing that site. So what I did is I copy and pasted my code base, I bought a new sketchy domain name, and I spent 6 to 8 hours redoing the site so it matched the new domain name. Like I changed the logo, the header, the images, the colors. I wanted it to make it feel like a different brand. So I probably spent 6 to 8 hours on that. Now, over the next couple days, this new website got indexed by Google. We started to get a lot of users coming into it. We started making money again, and everyone, for the most part, was pretty happy. But about a week later, this site got banned as well. And so I thought, the first site getting banned was a fluke. The second site getting banned, something weird's going on. So what did I do? Well, I just copy and pasted the code base twice more. I bought 2 new domain names, and I spun that shit up. So I spent, a good 16 hours on these next 2. And again, same thing happened. So launched the website, it's going pretty good, started making money again, and then banned about a week later. So at this point, I'm starting to panic because this website was generating millions of dollars. It was a big deal. It was making a lot of people money. And I like money, so I was freaking out a bit. So what I did is I just went on a copy-paste rampage. I don't know if any of you have ever done this. I am certainly guilty of it. So I copy and pasted the shit out of this code base. And I spent the next, I want to say 4 to 5 months, maybe something like that, playing this constant cat and mouse game with Google of trying to launch these new really spammy websites designed to drive affiliate sales. And in the end, it didn't work out. But coming back and thinking about this experience, this whole process was just brutal. And the reason it was so brutal is because what I should have done is if I was going to do this the right way, I would have variabilized and templatized my one code base. Because the problem that I had here wasn't that I just had to launch all these new websites. The problem was that I wasn't smart about it. I was just in, constantly stressed state. I was going in there. Whenever I added a new feature, I would literally go into all of these code bases, 20, 30 code bases, and start copying and pasting code around. It was fucking a nightmare, obviously. So anyways, the lesson learned here is don't do this. It's terrible. All right, next up, the next factor in the 12-factor application is all about dependency management. Now this is also one of those topics, sounds pretty straightforward, right? You have dependencies and you need to declare and isolate them. So how does this work? Well, when you're building an application today, the first thing you do is you declare all your dependencies, right? So maybe if you're building a Node application, you have some JavaScript dependencies you define somewhere in a package.json file or something like that, but you list it out. The next thing you do is you isolate those dependencies. So you're going to take it, maybe you install all the dependencies using NPM or whatever package manager you're using, and that's going to take all your dependencies, install them into this nice little environment so that you can run your project. Makes perfect sense. Now, the way I messed this one up is a little more complicated. So this happened approximately 7 years ago. I was working on a fun project on my free time. It was this image optimization API. Now the concept for this is pretty simple. You're a developer and you have an image that you would really like to optimize. Oh, it's not coming through very well, but it is a really cool picture of a crow holding a knife. All right, you have to trust me on this. Now, you want to optimize the image. So what you do is you send it to the API service. It is going to optimize the image and then send it back to you. And the way that it worked, the way that it was able to reduce file size was, basically I had a VPS server running, I believe it was on some shared web host, and I went out and I installed all of these really popular Linux command line tools. There's something here, OptiPNG, JPEG Optim, GIF-Sickle. These are some popular command line tools that you can use to optimize images based on the file format. And so the API service was pretty slick. Whenever developers send an image to my service, I would basically look at the type of image they sent me. If it was a PNG, my application would just shell out to the command line and run the OptiPNG tool to compress the image, take the resulting image and send it back, and so forth and so on. Now, this service was working flawlessly. I launched it, I put it on a subreddit, it got sort of popular, had a lot of people using it, and I just didn't really think about it for a few months. Well, after a while, maybe 5, 6 months, something like that, I get a bunch of alerts from my hosting provider basically saying, hey, you're throwing off a few 500s, you should look into it. So I go back and I look into it and I realize, well, my service is doing great, it just can't handle the amount of requests that it's getting. So I decided, all right, I'm gonna scale this thing up. So what I did, I spun up a second server, copied my code base over, ran the npm install. This was built in an early version of Node at the time. Got it all working. All these web servers were behind a load balancer, so I fired off a single request to the API to test it out. It worked, so I went to sleep. And the next morning I woke up, and there was a ton of error messages, all right? And basically the gist of it was that the load balancer had routed my test request to the first server that was working, and not the new server I provisioned. And the reason it wasn't working is because I forgot to install all of these command line tools on there, right? This is one of the things about dependency management that can sometimes be tricky. We often, as developers, think about dependency management as like your JavaScript dependencies, your Python dependencies, but a lot of the time, dependencies are a more holistic thing. It's anything your application requires to function, like command line tools, for example. So this is how I learned the lesson about dependency management. All right, next, let's talk about storing configuration data. In 12-factor apps, what you want to do is you always want to store configuration data for your application in environment variables. And I'm sure you've seen this quite a bit if you're a web developer. You might need to store a database URL or some API keys, the amount of threads you're going to run in, things like that as part of your application's configuration. And in 12-factor apps, you ideally want to package all these things up and stick them in environment variables because it's a uniform interface that any application can work with regardless of where those variables are stored. So today there's a lot of tools like AWS Parameter Store, there's Vault from HashiCorp, all sorts of cool tools that make this easier. Now, back in the day, after I dropped out of school, I was doing a lot of telephony work. So I got involved in the telephony programming industry. And most of the software that I wrote back then was based around this open source phone system called Asterisk. If you haven't heard of it, it's a really cool program. It lets you automate things like phone calls, SMS messages, anything telephony related. And when I started working at this company doing telephony work, the project was still co-located on physical hardware. This was a long time ago, before cloud providers had really taken off. And one of the first things I wanted to do was move this thing to the cloud so I could dynamically scale it and make everything really nice and clean. So what I did is I set up a test account with Rackspace, which was a really big cloud provider at the time. And in order for me to start automatically scaling my code, I had to interact with Rackspace, automatically create and provision servers, do all of this stuff, right? So I went and created a Rackspace API key. Now, also, I should mention that my code was hosted on GitHub, just like this. And so what I did is in the sense of urgency where I was trying to get things working really quick, I just went ahead and cheated and I copied my API key, I just hard coded it straight into my code base on GitHub. Now, you all might laugh and say, wow, this guy's a total noob. But back then, GitHub bots weren't a real thing. So I was quite surprised the next day when I woke up and someone had basically ran a GitHub bot to look for noobs publishing their API credentials like me, grabbed my API key off of GitHub, and then immediately started making requests to Rackspace, creating really large instances and running Tor exit nodes, which used a lot of resources, if you aren't familiar. So when I woke up in the morning, the first thing I thought was I had this massive wall of emails, and I just thought, fuck. And it had nothing to do with work. It turns out Rackspace, their sales team reached out to me and basically said, hey, we can see you really love using Rackspace. You just signed up. You've already spent $25,000, which is about 23,000 euros, I believe, which is a lot of money. And I was I was completely broke. I didn't even have a credit card that would accept a $25,000 bill. Thankfully, Rackspace was super amazing, so they canceled it out. They said, don't worry about it. Noobs like you happen all the time to us, which was very kind of them. But the lesson learned here is don't cheat. I was just really trying to get stuff out fast, and I said, screw it. It's just a test account. Anyways, it's not a big deal, but bad things can happen when you're not careful, so don't be an idiot like I am. All right, next. Let's talk about backing services. So in 12-factor apps, you always want to treat your backing services as attachable and detachable resources. Now, I realize that sounds sort of confusing. When I say it out loud to myself, I think, wow, there's a lot of buzzwords in there. But let me explain how this works. So you have your application running in production somewhere, right? And that application probably relies on a lot of backing services, right? Maybe if your app is sending emails, you have an SMTP service that you need to work with. Maybe if your app is storing files, you're using an Amazon S3 bucket to store files. Maybe if your app is using a database like Postgres, you have a database URL that you need to worry about. And the idea here around backing services is you want to treat these things as attachable and detachable resources. Like you should easily be able to switch out the database that your app is using. You shouldn't need to update code for that to happen. All you should need to do is be able to update some configuration. Otherwise, it's just going to be a nightmare when you need to change infrastructure around in the future. So, how did I screw this up? Well, this is actually a picture I drew myself. I don't know if you can tell because it's so quality. But this is me as a young developer when I was probably 12 years old or so. And when I started programming, I immediately fell in love. I went to the library, I got all the books on it. I was just working in my room constantly. And I was a super introverted, nerdy little kid. I never had any outside friends basically. And so this fit me very well. And like a lot of young programmers who are total noobs like me, I thought, all right, I need to make a blog because I'm doing some cool shit and the whole world needs to know about it. And I built this blog, and it was terrible quality, as you can imagine. I had a shared web host, and that web host was running MySQL on localhost with no username or password as one of those cheap rent-a-hosts. And I built my website on here in PHP over the course of many years. I worked on this project all the way up through school and everything. Now, when I first got to university, I still was a really nerdy, introverted kid that had no friends, but was pretty good at programming at that point. And so I thought to myself, all right, well, how are you gonna make friends? You gotta have a strategy here. And so the best thing I could think of was I should just give out free pirated movies to everyone. Because everyone loves free shit, that's a fact. And at the time, Netflix didn't exist like the online version of Netflix. We just had the the DVDs in the mail situation. And so what I did is I signed up for Netflix in the States, and I subscribed to their 4 movies a month plan, or 4 movies a week plan. So what they would do is every week, they would mail me out a bunch of CDs with movies on them, and I would take those, I'd rip them to AVI files, and I'd upload them onto my website. Then whenever I met friends at school, I would say, hey, it's nice to meet you, just FYI, if you want to check out some movies, here's my personal site, it has a bunch of shit, just feel free to use it. And it worked. I made a lot of friends, it was awesome. It was super cool. So if you're looking to make friends in school, I highly recommend this approach. Now, this went really great for me, I did make friends, until one day I was doing this and I ran out of disk space. Which you could obviously imagine is absolutely going to happen. So what did I do? Well, I thought to myself, Randall, you've done it. You've built a successful service that people enjoy using. Congratulations. Now it's time for you to make amends for all this terrible code that you've created. So this project had amassed over time, over 6 years or however long I was working on it, it had transformed from a few PHP files to hundreds of PHP files and thousands, maybe even tens of thousands of lines of code. It was just an absolute disaster. So what I did is I said, okay, first thing I'm gonna do to clean this up, I'm gonna migrate the MySQL database to a separate host. I'm gonna make this really nice and clean. So I set up a new MySQL server, copied all the data over into it, and then I went back to update my code base to start talking to the new database. And that's when I ran into a bunch of problems. Now, the problems I ran into were basically that in this code, I had always assumed that MySQL would be available on localhost and that it would have no username and password. And if you've ever written PHP code, you've probably seen a line of code that says MySQL_connect. Well, I had that sprinkled throughout hundreds of files, multiple times within each file. And so what I quickly came to realize is that it wasn't that easy to actually update this database. And had I known about the 12-factor app design principles when this happened, when I was learning these things originally, I don't think I would have made this mistake because I would have gone in there, had a single environment variable pointing to my database that I could have updated to localhost or to remote host or whatever it was. And that way I wouldn't have had to spend tons of time in the middle of school with finals working on stuff. As a matter of fact, maybe that would have helped me not drop out of school. I'm not sure, but it might have helped. All right, next up. Let's talk about the build, release, and run factor. So the rule here is you always want to separate these stages in your application lifecycle out. So when you're building a project, you're writing code, right? You're in development mode. Now at some point, you're going to write some code that builds your project. So you have a build pipeline of some sort. So if you're using Java, maybe you compile your stuff into bytecode before sending it off to the JVM or whatever Java developers do, I guess. You're gonna have some configuration data. These would be all the environment variables, API keys, all that stuff that your application uses. And then you have a release. And what's really important to think about here is these are separate stages. You write code, you build it, you take the build, you merge it with some configuration data, and this creates a release of some sort. Now, you can call this a release artifact, you can call it whatever you want, but the release is actually the thing, it's the mix of the build and the config that you would deploy and test and do stuff like that against. Now, the way I screwed this up is, I sort of mentioned it before, but when I was a kid, I was sort of a script kiddie. Like, I didn't really know that much. I was just hacking around on things. This image doesn't look too great, but it's from the movie Hackers, my favorite movie of all time. And basically, the way I would write web code back in these days is I was in my room and I had a desktop computer. And I also had that shared web host that I told you about earlier. So when I would write code, essentially what I would do is I'd write code, then I would copy the code using SCP onto my web server. Then I would just go and refresh the browser and test the code out, because it's all PHP code, pretty simple. And if you've ever done this before, you will quickly realize how slow this is. Like, you start just looking at the bytes per second that are being transferred from here. It's terrible. And so I would get really impatient. What I would do is I would just SSH straight into the host as root. I would just edit the code live on the web server and test it out. Now, this doesn't sound that bad to me. I know people are going to judge, but whatever. This was actually fantastic because I'm testing things out quicker. It felt pretty great. The problem I ran into had nothing to do with this. The problem I ran into is that I wasn't using version control, and I didn't know about version control. And so I was basically my own Git compiler in my head. So I would write some code here, then I would write some code on the web server, then I would try to keep these versions of code together. So like, if I got something working here, then I would go and copy some files back here, but then maybe I'd write some code here and copy the files back there. It just became very untenable, and I was extremely frustrated. And the reason I was so frustrated is because I didn't keep all those stages separate that we just talked about. If I had done that, then I wouldn't have been in this mess. So anyways, that was my lesson learned there, and that's how that factor works. All right, next up, let's talk about processes. Now, when you're building a 12-factor app, your app should really just be one or more stateless processes that are running, with the keyword here being stateless. This is super important. Has to be stateless. And the way that I screwed this up was I was working at this telephony company, and we were building this free conference calling software. And it was very, very exciting. So it ran in a data center on these physical servers with PRI lines plugged into it. And basically, we had a few of these servers in a rack. And what we would do is when people would call into this service, we would put them in a conference call for free. And we had different conference phone numbers that were routed to different servers. Now, everything was fine here. And one of the cool features of our service that distinguished us from all of our competitors was this. We allowed people to call in who created a conference line and customize all of their voice prompts. So they could call in, they could customize their voice prompts, and whenever they did this, what would happen is we would just store those voice recordings on the server in which they called into. Now, this worked totally fine for a while, until one day, of course, one of the servers went down. And so when the server went down, I talked to the data center, they rerouted the conference numbers from here down to here, and I thought everything was gonna be totally fine. But the problem I realized later is that, well, those voice recordings were only here. This wasn't a collection of stateless processes. This was a collection of stateful processes. They required all this, audio data state. And because I wasn't packaging that up with the process itself, I was running into issues. So I had to make some really painful emails and phone calls to users telling them, hey, I know you spent a lot of money hiring a professional voice actress to record all these nice prompts, but they're all gone and you need to do it over again. So that was terrible. All right, next. Let's talk about port binding. This one's really simple. This is true not only for web apps, but just a lot of services in general nowadays, but I think there's still a lot of truth in this. But whenever you're building an app, a web app, you want to make sure that you expose your apps via port binding. There's a lot of reasons for this, but the main idea boils down to this. If you have a web server running somewhere, back in the old days, what you would do is you would have your app bind itself to port 80, port 443 for TLS, things like that. And this has sort of always been like a bad idea. And the reason why is that it really shackles you to your infrastructure. So if you're building a web app and you're specifically telling it to bind itself to one of these ports, it's generally not a good idea. What you should do instead is have your routing infrastructure tell your applications which ports to bind to in a dynamic way. So if you're using any fancy platform as a service companies today like Heroku, this is how they all function behind the scenes. They run really large instances and they map inbound requests to ports on your instance. So you can have hundreds or thousands of applications running on a single server, and all this stuff is handled really nicely. I don't have any sad story here because this is the one thing that I haven't screwed up. Thank God. All right, next, let's talk about concurrency. So in 12-factor apps, when you get to a point where you need concurrency, you always want to scale your applications up via the process model. So what does this mean? Well, basically, every application, as we talked about, is just a collection of processes, right? So maybe you have a single web process that is handling incoming requests and returning responses. Well, if you're building a 12-factor app, what you want to do is when you run out of throughput here and you need to add more capacity, you should just be able to add a second web process and load balance incoming requests between them. But applications have other types of processes too, right? You might have worker processes processing items from a queue. You might need to scale that up and down dynamically based on what's going on in your application. There's all sorts of things you can do. So this is sort of how you want to scale things. Now, the way that I screwed this one up is, again, going back till I was about 15 years old. And I was working on this project that to date was I think the coolest project that I ever built. It was something that I felt extremely passionately about. I thought it was gonna be the next big thing. I was super psyched. And basically, it was just an IRC web app. Now, if any of you haven't used IRC, it's just an old chat room style stuff. And when I was growing up, I met a lot of really awesome programmers on IRC, and I learned a lot about programming from it. But there wasn't a way to easily connect to IRC without basically needing to be a programmer. Not that many people understood the software you had to use to connect. So I started building a web app that allowed people to connect to IRC rooms. The way it worked is people go to the web app, then they could join all the chat rooms they wanted. And then I started showing this prototype that I built to a few friends, and they were psyched. They were like, oh my God, this is amazing. And they started using it all the time. And so I had that positive feedback and I had that momentum going, and I was just so excited. So I decided that I should build this thing properly so it can scale up and down, because managing a lot of persistent connections like this is actually extremely difficult. So what I did is, at the time I was building everything in C. So I wrote this entire thing in C, which, first of all, terrible idea for a website. Second of all, I decided to go all in. So instead of using simple processes that I could scale up and down like what we just talked about, I decided to turn this thing into a Linux system daemon. Now, I'm not sure if you're familiar with the concept of Linux daemons, but basically they register themselves with your init system and they spawn off lots of child processes and things like that. So basically, whenever people join a chat room, I'd spawn off a bunch of threads and I would have to manage them and do a lot of inter-process communication and all of these relatively complex things. Now, the problem I had is that while this worked okay, after my site started getting a decent amount of usage, I would run into tons of issues. So a process would be killed, and that process would cascade failure, which would kill the daemon, which would restart. And eventually when this happened, everyone's chat room connections would drop and be reset, which is an incredibly bad user experience. And I would love to tell you that this story has a positive outcome, but it doesn't. I worked on this for 6 months, poured my heart and soul into it, and I can never resolve these really complex issues that I was having with basically shared memory and memory locking between these threads. And at the time, I just wasn't sophisticated enough to handle something like that. So in retrospect, I think that what I would have liked to tell my younger self is, hey, if you're doing something you need to scale out, do it via the process model. Have simple, self-contained processes that you can easily scale up and down. Don't try to re-implement an operating system like I did. Just keep things really simple and you will be fine. All right, next. The next factor is all about disposability. Now, the rule here is you want to maximize the robustness of your applications by having them start up really quick, shut down really quick, and just in general, be really graceful. So what do I mean by this? Well, here are the rules. First rule, shut down gracefully when a SIG term is received. So when an operating system wants to shut down your process, it's going to send you a SIG term signal, and you can catch that signal, and that gives you an opportunity to clean up the state of your process before you actually shut it down. Now, this is really important. So if you're in the middle of building a worker process, for example, where you're processing items from a queue, you would finish processing the item and then shut down. The next rule is always shut down within a few seconds. When you don't shut your application down within a few seconds, it causes all sorts of problems because the operating system or the scheduler or whatever is launching these processes isn't going to know if your process has frozen or if it's actually working properly. So shut down quickly. And finally, you want to be robust against sudden death. So when you're designing and architecting your projects, you don't want to write stuff such that, let's say you're in the middle of processing this item from a queue and your process is just killed. That shouldn't impact your application negatively. Another worker should pick up this task and process it eventually, but you want to be really robust against sudden death so you don't have a lot of problems down the road. Now, the way I screwed this up is also going to go back to that telephony conference calling application from before. So at this point in time, I had moved the application onto the cloud, and I could dynamically scale it, kinda. So the application would load balance incoming calls, and basically, I had some processes running to handle them. And essentially, I had just finished writing my own auto-scaling software to add and remove processes, as we just discussed. But the problem I ran into is when I tested it locally, everything worked. But then when I deployed things into production, I would get problems like this. The process would start, but then after a little while, it would just fail and then just be restarted over and over and over again. And it took me a little while to figure out why. And the reason why this didn't work is because essentially, and I'm dumbing this down a bit, but my startup routine for these processes looked something like this. The first thing I did when I started up was I downloaded the audio files necessary for these teleconferencing lines to be served, just like I talked about before. So I tried to make them stateless. Then after that was done, I would bind myself to the appropriate port so that the load balancer would know that my application was now online and would start servicing more requests. And the problem was this download bit right here. And the reason why is that instead of just downloading the audio files a particular process needed, I was downloading every audio file ever created, which was hundreds of gigabytes worth. And so basically, in the real world, when I would run this stuff, the process would start, and then it would start downloading hundreds of gigs of files. And because that takes more than 30 seconds, the auto-scaling software I had would say, well, this application hasn't bound to the port, and it's been 30 seconds, it must not be working. So it would just kill it and then restart it, so it would never finish. And of course, in testing, I had all the files set up locally, so I didn't have this issue. But this was a really hard thing to debug. So again, keeping this stuff simple and keeping it stateless is really important. All right, next, let's talk about dev prod parity. So the idea here is you always want to keep all of your development environments as similar as possible. So development, staging, production, they should all be identical. Now, this is one of those rules that I'm ashamed to admit I break all the time on purpose. And I always feel bad about it, but I'm just really lazy. And I'll show you what I mean. So just a couple months ago, I was building this website, and the website was pretty simple. It just wrote some data into a Postgres database, nothing fancy. And I was working on it, and I thought to myself, well, I just got a new laptop, and I want to work on this project, but I don't really want to install Postgres and like get it all set up the same way that I have in production. So I'm just going to cheat and use SQLite. Now, if you've ever used SQLite, it's like my favorite database of all time, okay? It's a SQL database, but you don't need a server to run it. It's fantastic. It just stores all the data in a single file. It's really convenient for testing things out. And so I wrote all my code and tested against SQLite. And again, both of these are SQL databases. They support the same commands and everything. So technically, when I deployed my code into production on Postgres, everything should have worked fine. But what happened instead is I got a bunch of varchar errors. And the reason why is because unlike Postgres, which sanely checks the length of a varchar field, SQLite does not respect that shit at all. It's like, do whatever the fuck you want, basically. So the lesson I learned is, even if things are pretty similar, don't treat them as such. Like, when you're doing stuff in development, try, if you can, to make sure that everything's the same version, everything's the same software. It makes your job a lot easier in the future. All right, next, let's talk about logs. You always want to treat logs as event streams in 12-factor applications. So what do I mean? Well, you have an application, it generates some log information, and there's a few rules you should generally follow. Rule number 1, logs should be ordered by timestamp. Makes sense. Rule number 2, logs should always be written to standard out. Just a general thing. And rule number 3, your application logs should consist of all of your process and backing service logs together. So what does that mean? Well, if you have an application and it has a Postgres database and a worker process, the logs for that application should have the not only the web server code, but also the worker logs, as well as the database logs combined into some form that you can search. So this story is the most damaging one I'm going to reveal to you today. And trust me, there are way bigger things that I've screwed up, but this one is definitely the worst I feel comfortable sharing on a stage. Basically, that conference calling application, the way it worked is we were making money every minute that people stayed on these free teleconferencing lines. We would make approximately 50 cents per minute US, which is a lot of money because we had thousands of users using these conference lines all the time. So the way everything was architected was something like this. I had a bunch of Astra servers that handled all the phone calls, and I had a web app that people could use to manage their their teleconferencing lines, and I had an API service I wrote, which was sort of the central source of truth for everything. So when a call came in, this conference call service would receive an API request from an Astra server, and it would say, okay, I'm going to log some billable call details. And all of these logs made their way into a file called calls.csv on that server. Now, the reason this is important is because once a month, what I would have to do is copy that calls.csv file from the server onto my laptop, and then I would have to do some data manipulation and then send it to the phone company, and that's how we would get paid. This is the way we made our revenue. And so one day, it's about halfway through the month, and I decided to copy the calls.csv file onto my laptop to do some analysis to see how much money have we generated so far in the month, where are we at, etc. And when I did that, I noticed something was a little off. The amount of calls that we had was the exact same as the prior month. And I was like, well, that's never happened. That's a mighty big coincidence. And then I had this sinking feeling in my stomach. Like, I just felt like if you go right down a roller coaster and you just feel like really sick. And then I slowly had the dread like go into my fingertips, and I started hitting up in the shell so I could see the last command I wrote. And what I did is I'd reversed the arguments to SCP. So instead of copying this file from here onto my laptop, I'd copied last month's file from my laptop and overrode the logs there, which, as you can imagine, is a pretty big mistake. So what I did, of course, is I went and I said, okay, it's not a big deal. I'll look at the logs from here and I'll be able to reassemble this, not a big deal. But in my naivete, what I had done is I said, well, hey, writing logs is actually pretty slow. Like, it slows stuff down. So I turned them all off here. Now, what I should have done, of course, is I should have had everything logging their stupid ass logs going into a log router somewhere that I could have reassembled this from, but I absolutely did not do that. So I had to make an extremely painful phone call to my partner and say, hey, we have a little bit of a problem. It was a terrible conversation. And that cost me about $500,000 US. That's, I think, 450,000 euros, something like that. So, terrible. Anyways, the final factor we're going to talk about today is the 12th one, admin processes, all right? So admin processes are tasks that you need to run as a one-off thing. So let's say you need to run a database migration. You need to alter something in your database. Well, when you do that, you have some command you need to run or something you need to do to like accomplish this, right? And what you want to do ideally is codify that, generate a task, like a function that executes from the CLI, something like that, check it into your code base, and then after that, you want to deploy it to your production infrastructure. And then in the same way that you would, for example, launch a new web process to scale up, you would launch a admin task process in production to run this database migration. And I screwed this up a couple years ago in like a major way by doing exactly what I just told you. So what I did is I was working on this new feature. And I was about to go on, and I'm not exaggerating this at all, it was the second vacation I'd ever taken. And the first vacation was an absolute nightmare. It ended up being terrible. So the second vacation I was about to take, I was doing a road trip from San Francisco down to Los Angeles. So I was working on this new feature. It was about 3 p.m. on Friday, and I was like, I have to get out of here, like immediately. And this feature was completely coded out. Everything worked fine on my laptop, of course. And the only thing I needed to do to make this work was alter a database table and add a new column. So I knew that I had to write some database migration code. I did that in like 2 seconds. And then I thought, well, I should deploy it into production and then run it and everything like that, but that's going to take at least an hour and a half. Like, it'll go through all the tests, it'll go through the continuous deployment pipeline, then I'll have to wait for all the servers to get the new code and then issue the stuff. And I thought, well, I only need to run this once. It's not a big deal. I'm just going to do it. So what I did is I just went ahead and ran the migration code on my laptop. And everything worked. I got output saying, hey, it showed me the SQL query that was ran. It said, successful in 34 milliseconds or whatever. And I said, sweet. So I pushed my code to GitHub, which triggered the deploy, and I pieced out of there. Started driving. So about an hour and a half later, just as long as it takes, ironically, for that deployment to happen, I get this angry phone call from my partner, and he's basically telling me, hey, there's no chance you broke the entire application, is there? And I was like, no, not at all. Absolutely not. There's no way. I deployed some code a while ago, but that was a long time ago. It is 100% fine. So later, I log in, I stop at a McDonald's, I'm using their free crappy Wi-Fi, and what I realized, of course, is I had forgot to update my environment variables that this was reading from. So instead of altering my production database, I had altered my SQLite database on my laptop, which, while, that is useful, it is not exactly what I wanted. So we had millions of user requests hitting this application per second, and it was causing all sorts of issues because it was expecting a database column to exist that didn't. So, I trashed the whole thing. So anyways, that sort of covers all the 12 factors. Now, I realize that this has been sort of a weird talk, but I want to leave you with one thing to go home with, okay? The point of all this is, some people are going to say, all right, Randall, you've been a total idiot. You've committed all these programming sins, and this is your problem. And here's what I like to think. Programming isn't black and white, right? There's a lot of gray area. Sometimes it's okay to code things in production. At least for me. Sometimes it's okay to skip writing a test every now and then. You're not going to die, usually. And so I guess the thing that I'm trying to say is I make mistakes all the time, and I've been programming for 19 years, and I'm sure all of you make mistakes, and even John Carmack, one of the best developers in the world, I'm sure he makes mistakes all the time too. So especially if you're a new developer, don't worry so much about making mistakes. Just worry about learning some of the patterns to try to avoid them as much as you can. So anyways, with that, I just want to say thank you very much for having me. If you want to see any more crazy stories like this, I have published some of them on my website. You can also check out Okta's website and tweet Okta if you want. We have some really cool articles and stuff about cybersecurity and things like that. And then the final thing I just want to say is I had a lot of stories I couldn't tell up here because they're way too embarrassing to too many people. So if you want to hear about it, come talk to me later. And thank you very much. Have a good one. I'll see you all at the break.